Remainder Theorem. Remainder Theorem. So the remainder theorem states that P of C is the remainder when the polynomial P of X is divided by X minus C. The divisor X minus C is then restated as X equals C. And let us start with an example. So here we have to find only the remainder if this polynomial is divided by X minus 3. So there are two possible ways to come up with an answer here. So one, by using your knowledge on how to divide such polynomial by X minus 3 using synthetic division. Doing so, we have X minus 3 be restated as X equals C by having the X minus 3 be equated to 0. And applying the addition property of equality, we will have this be added by 3 as well as the other side of the equal sign. And now we have an X be equal to 3. So this will be the coefficient that we will be using in our synthetic division, while the polynomial is already written in the proper order as well as it has complete terms. So we can immediately write the coefficients of this polynomial in the synthetic division process. Having this constant written first as 3, followed by the coefficients 1, 4, 3, and negative 2. And now, let us start with the synthetic division, bringing this all the way down here, and we are multiplying 1 with 3, which is positive 3. Adding these two numbers together, we have a positive 7. Then again, we multiply these numbers, and we have a product of 21. And 21 plus 3 is 24, and multiplying this, that gives us 72. And adding these numbers together, we have 70. So this will be the remainder once we divide such polynomial by x minus 3. But what does the remainder theorem tells us is that we can actually have the polynomial p of x be written as p of c. Since we have restated the divisor of x minus 3 as x equals 3, like this, then we should have an assumption that the value of x is equal to 3, such as writing the x here by such value of the constant, having this p of c be p of positive 3. Doing so, we have to change all the x's in the polynomial p of x with such value of the constant. Doing so, we have this x be equal to 3, as well as this x be equal to 3, and we are simply writing the remaining parts of this polynomial. And then again, we have the x be equal to 3, and now we will have this resulting equation. And now let us simplify this expression. So first we have 3 cubed, which happens to be equal to 27, plus first we have to evaluate 3 squared, which happens to be 9, and multiplying such 9 with 4, we have 36. And 3 times 3 is 9, and we have a minus 2. And combining all these terms, we will have 27 plus 36, which is equal to 63, plus 9, we have 72, minus 2, we will have 70. So notice that this is the same with this answer. And now let us have another example. So again, we have to find only the remainder if this polynomial is divided by x minus 1. So notice that if we apply synthetic division for this problem, since that the degree of the polynomial is 100, therefore we have to write so many zeros before we have the last coefficient of 1. So it is not practical to do so. So in this particular problem, I will only apply the remainder theorem, for which the remainder of the polynomial is given by p of c. So this simply means that we should identify first the value of the c, having the divisor of x minus 1 be equated first with 0, and applying the APE to get the value of x. We have to add a positive 1 to both sides of the equal sign, giving us x equals positive 1. And since that we have restated the divisor x minus c to x equals c, therefore this will be the value of c. And having the p of c be p of 1, then we have to replace all the x's in our polynomial by a positive 1. Since we only have this x in our p of x, therefore we only need to change this variable to 1, and writing the remaining parts of the equation, then we have this expression right here. And now to simplify 1 raised to 100, it simply gives us a 1. And adding 1 with another 1, it gives us a positive 2. So that means your P of 1 is equal to 2, and that will be the remainder for this problem. And let us have another example. So this time, we would like to find the value of k when the polynomial 3x squared plus kx plus 4 is divided by x minus 1, with such condition that the remainder is equal to 2. So remember that the remainder of the polynomial is given by p of c. Therefore, we can have this be the positive 2 in the given problem. Since we only have to replace the excess by the value of c, doing so we have to restate the x minus 1 to x equals 1. To check, we apply the APE by adding a positive 1 to both sides of the equal sign. It gives us x equals 1. So therefore, we only need to change all the x's here with a positive 1. So notice that we have here the k, and since the x is equal to 1, this will be our resulting equation. So we only need to simplify this equation for us to have the value of the k. Having this 1 raised to 2 first, which has the value of 1, and now k times 1, it gives us k. Next, we have here 3 times 1, which happens to be 3, but here we still have to combine these similar terms. 3 plus 4, it gives us 7. Since our goal here is to find the value of k, therefore k must be isolated in this side of the equal sign. And we must apply the APE for that. Adding the negative 7 to both sides of the equal sign, it gives us the value of k, which is negative 5.